Exactly right. And you have no jurisdiction over a church if it is a real church. Now, for the last 100 years, so many churches have been incorporated, the average building inspector's never heard of that, and it drives them nuts to even consider that just maybe we don't have jurisdiction. But that they don't, okay, if it's a real and true New Testament church. Now, churches ought to build their stuff better than the county requires anyway, and we try to at our place, but they simply do not have jurisdiction. Okay, second question. How do we see stars that are billions of light years away? There is no question there are an awful lot of stars out there. The Bible says in Nehemiah, Thou, even thou art Lord alone. Thou hast made the heaven of heavens, with all their host, the earth and the things that are therein. God created the heavens. Now, according to the evolution theory, stars evolve. It's interesting. Nobody's ever seen one star forming. Some have argued, well, in Crab Nebulae, we see some bright spots that we think are stars forming in this nursery that produces stars. Just a minute. You wouldn't need to be a rocket scientist to figure out. It could be you're not seeing a star forming. You're seeing the dust clearing and a star showing that was already behind it. I mean, if this had to go to a court of law, any freshman law student would make that argument, and you couldn't prove that's wrong. So there would certainly be very reasonable doubt that we're not seeing stars forming. Nobody's ever proven a star is forming. But yet there are trillions of stars out there. So if stars really evolve, star births ought to equal star deaths, and yet we don't see that happening. We see stars dying, exploding, burning up, novas and supernovas happen, but that's the opposite of evolution. We never see one form. The Bible says in Genesis chapter 1, God made the stars to be for signs and for seasons here on the earth. So, God made the stars. The Bible says He actually counts the number of the stars. Not only how many there are, but each one has a number, and He knows that number. When the Bible says He numbers the hairs of your head, it doesn't mean He knows how many hairs you have. He means He knows the number of each hair. This is hair number 174,219. He knows the number of every hair. And He knows the number of every star. There are enough stars out there that everybody on earth can own 2 trillion of them to yourself. Plenty to go around. And here we fight over a little bit of real estate. God's got loads of stuff for us out there in heaven. Okay, the Hubble telescope was asked to focus in on a dot. And for 10 continuous days, they spotted this. They looked at this one spot north of the Big Dipper, or above the Big Dipper. This spot is about the size of a grain of sand held at arm's length. After watching it for 10 days, they thought this spot was black. There was nothing there. But after 10 days of continuous viewing, they discovered there are more stars than they could count. In that spot they previously thought had nothing. Now, even the evolutionists, like Stephen Hawking, who hates creationists, Stephen Hawking said, stars are so far away, they appear to us to be just pinpoints of light. We cannot see their size or shape. So how can we tell the different types of stars apart? For the vast majority of stars, there is only one characteristic feature we observe, the color of their light. What he said here is stars are so far away, all we see is the color of their light. We cannot see their size or shape. When you look at the sun through a telescope, of course, you can see the various, flames leaping off and all this kind of stuff. You don't see any of that with stars. You get the biggest telescope in the world, all you see is a dot when you look at a star. You do not see the features of a star, so keep that thought in mind. If you're going to tell the distance to an object you cannot touch, like a star, or across Grand Canyon, the way you tell the distance to something you can't actually go measure, one way to tell the difference is to use trigonometry. I taught high school trig for years. It's not that complicated. If you get 2 observation points looking at a third point, if you know the distance between your observation points, and you know the angle that they form looking toward this third point, you can actually calculate the unknown distance using sine, cosine, or tangent. Simple high school trig. I could teach you how to do it in 15 minutes if you don't know. Well, we got this same problem when you're looking at stars. The Earth is only 8,000 miles in diameter. So if 2 people are on opposite sides of the Earth looking at a star, 8,000 miles is nothing compared to star distance. So we need to get a greater base on our triangle. So what they've done to enlarge the base is they look at the star in January, then they look at the star in June, and you now have a huge base on your triangle. The problem is the distance from the sun to the Earth is 93 million miles, which is 8 light minutes. It's called 1 astronomical unit, which means the diameter of our orbit as we circle around the sun is 16 light minutes. Now, that's a big number if you measure it in miles, but if you measure it in light minutes, it's not that big. This little yellow dot on the far left here represents Earth's orbit around the sun. 16 light minutes. Now, if you were going to look at a star that was 1 light year away, and apparently none of them are that close, you would have a very skinny triangle even to measure 1 light year, because a year has 525,948 minutes in it. That's about like having 2 surveyors set up their instruments 16 inches apart and focus in on a dot 525,000 inches away. What we're going to do here is translate the light minutes into inches, so the analogy makes sense. Well, 525,000 inches is 8 1/4 miles. Let's get 2 guys up on the roof of the church with transits, powerful telescopes. We're going to park them 16 inches apart. They're going to focus in on a dot 8 1/4 miles away. Would you agree that would form a very skinny triangle? Real skinny. That is for 1 light year. Now, if you want to measure 100 light years, you have to move your dot 826 miles away. At 1 light year, it gives you an angle of 0.017 degrees. At 100 light years, it's 0.00017 degrees. I don't think that's measurable. Some have argued, though, they can measure 100 light years. Well, I don't think so, but I'd like to see the proof of that. But I'll give them 100. I don't think you can tell exactly where you were 6 months ago on opposite sides of Earth's orbit, for one thing, to establish your other base point to get this exact angle. This textbook says parallax trigonometry can be used to measure distances out to 100 light years. Now, some have argued, oh, we've got better telescopes now. We can go out 1,000 light years. I'd have to be demonstrated. You know, you'd have to prove that to me, but maybe we can, okay? Even if you can measure out 1 billion light years, that still does not prove the universe is 1 billion years old. I mean, you don't need to be a genius to figure this out. If you're seeing a star 1 billion light years away, you would have to assume the speed of light has been the same all through history or all through space. See, a light year is a distance, it's not a time. If something could travel 1 billion light years in 1 second, then it's not a time when you say it's 1 billion light years away. It's a distance, not a time. So some things to consider. Number one, we cannot measure distances accurately beyond 100 light years. And I would even question the 100 as far as accuracy. You start to really get some wild numbers when you get out there. Secondly, nobody knows what light is. We certainly don't know that it's always traveled the same speed. The whole theory behind a black hole is that light can be attracted by gravity. Now, if light can be attracted by gravity, then the speed of light is not a constant. You can't have your cake and eat it too. The light is not a constant. Back in February of '99, Houston Chronicle ran an article telling